everybody. So in this video, I'm going to talk about adding a point to a scatter plot, which is influential points. Okay, so the premise is you already have a data set X and Y that is put into a scatter plot, and you already have a line of best fit. So what we want to look at is what happens if you add another point to this scatter plot. What changes will it have? So we're going to look at two different scenarios. One in which we add a point that is close to the line of best fit, and one where we add a point that is pretty far away from our line of best fit. So in our first scenario here, generic XY scatter plot here. So I have my points, there's my line of best fit. So what we want to look at, and I'll do this in red here, is what if we added a point and we find out if you add it on, it's going to be either right on top of the line or it's going to be pretty close to being on top of that line. So what we want to know is, what does this change? Okay, what does it change as far as our slope, our y-intercept, our correlation coefficient? So remember, the line of best fit is trying to account for every single line and try and fit this data and show this trend as best as possible, in short. So if I add this point here, this new point fits the trend that this line is showing, okay? It fits the trend. So if I added the point, I don't think my line would change a whole lot. I mean, we might be talking very, very tiny decimal changes here and there, but we're going to talk in generalities. How do things change? So if I add a point here, if I was going to write or draw a new line of best fit, including this point, it's probably going to be pretty darn close to my original line, which was in blue. So if my line is exactly the same, then surely my slope, which is how much we rise, run, etc., that is going to stay the same here because we're still continuing that same trend. We're not really tweaking or changing our line a whole lot. Same with the y-intercept, where I cross that y-axis is still generally going to stay the same. We're not going to see drastic changes there. And yeah, maybe if this red point was slightly above or slightly below, you're going to see very, 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 very tiny changes. But the fact that this point fits the overall trend of our line, you're not going to see changes in these two. Now let's talk about that correlation coefficient. Remember, that is R. And what we're looking for here is it describes the direction and it describes the strength of this fit. So as far as direction, we're staying the same. Direction's not changing. But the correlation coefficient, again, it really talks about strength there. So if I'm adding a point essentially on top of the line, things should be getting stronger. Okay, the correlation should get stronger. So our correlation coefficient should get stronger. We just got to be careful about, is it going to increase or is it going to decrease? And remember, that correlation coefficient is going to run from 1 to -1. So if you want to get stronger, you're either going to move closer to 1 or you're going to move closer to -1. Okay, so since this line is going upwards, our line of best fit has a positive trend there, we know the correlation coefficient already is somewhere positive, so that correlation should increase. It should increase and get closer to 1. Okay, should get closer to 1. Again, correlation coefficients talk about strength. How well are the points clustered and how tightly clustered are we around this line, or how spaced out we are. So you're strong when you're tightly packed and clustered. You're weak when you're really, really spaced out. So since we're adding a point on top of the line, we're getting stronger. So in this situation, we are increasing. If I had a scatter plot which was showing a negative trend and my line was showing a negative trend and I was adding a point on top of the line, we would still be getting stronger. But since we have a negative trend, my correlation coefficient would be somewhere over here. So in that way, to get stronger, you would have to decrease to get closer to -1. So what I don't want you to get stuck into is automatically assuming increase or decrease. It depends. It depends on, is your correlation positive or is your correlation coefficient negative? So you got to be careful about that one. So let's talk about one other scenario. So again, have a generic scatter plot and a line of best fit here. What if we added a point way down here, okay? So it doesn't fit the trend of our line, okay? It doesn't fit the trend of our line. The fact that it's far away from all the other points doesn't really guarantee it's a bad thing because, I mean, you could add a point that's way over here, but it follows your line. It's all about where this point is in relation to our line. So if I added a point down here, my line's probably going to change a little bit. I'm still going to have to try and fit as many points as possible, but I might do something like this instead to try and fit every single data point. So even looking at it, going from my blue line to my red line, there was a pretty drastic change there. So let's go through and see what exactly changed here. So my slope, we were going up in this direction. We're still going up, but we're going up by less. So what's happened here to my slope is it decreased. It decreased, okay? My line had to adjust and come down a little bit. That's a decreasing of a slope. If I would have added a point way, way, way up high, you're probably going to see the line go upwards, and that would be an increase. So again, pay attention to where that point is. Above, below, definitely makes a difference. My y-intercept, originally I was down here, but my new y-intercept is now up here. So my y-intercept just increased. It increased. And again, pay attention because it depends on where's this point at, above or below. So that's why I like to draw and kind of do, it's very rough, but draw my own new line and just look at what changed, okay? I'm a very visual person, so that really helps me see there. It could decrease there, don't just automatically assume, so it depends, because if we would have gone way up and put a point up here, my y-intercept's going to decrease, so be very careful. The bigger thing to focus on here is the correlation coefficient, which again, like up above, it's all about strength. How closely do my points fit around the line? So we were pretty tight beforehand, but now because of this new point, which, what we're going to call it, it's an influential point because it's drastically changing a lot of things here, it's going to change my correlation coefficient. We went from pretty strong to something that's a lot more spaced out now when you look at the red line compared to the points. So if I'm weaker here, let's note that things are weaker, but again, pay attention. Pay attention to where your correlation coefficient was originally, and then you'll know whether it's going to increase or decrease, right? Because remember, 1 is strong and -1 is strong, but 0 is weak. So if I want to get weaker, I need to get closer to 0. So if we were on the positive end, we're going to decrease to get closer to 0. If I was on the negative end, I'm going to have to increase to get closer to 0. So it really depends on what was your correlation coefficient originally, and then figure out would you have to increase or decrease to get weaker. So since we were moving in a positive direction originally, I know my correlation coefficient was somewhere on the positive side. So if I want to get weaker here, I would have to decrease to get closer to 0. Okay, so by adding this point that doesn't really fit the trend of our original line, this is what we call an influential point because it is going to drastically change our slope, y-intercept, and our correlation coefficient. Whereas when we add another point that just fits the overall trend, some things stay the same, only certain things will change, okay? So this was a quick overview on what does adding a point to the scatter plot do and what are influential points.